So if S is any sample space, then a function which is attaching the outcomes to the real number, that function we call it as a random variable. Now, just to closely observe this one, these outcomes are converted to
Real numbers.
real numbers. That what real numbers it is assuming decides the nature of the random variable. It may give 0 or 1, 2, 3, 4 like that, one possibility. Or it can be continuously all real numbers.
Yes, sir.
Either all real numbers or a part of the real numbers, some interval. For example, I pick up a person and x is the height of the person. Then it is not that person will be 4 feet and directly another person will be 5 feet. There will be so many people in between 4 feet and 5 feet, 5 feet and 6 feet. Then that particular height or particular weight, that will be random variable examples. Now, if a random variable, okay, it is called as discrete random variable if it assumes either finite number of values or countably infinite number of values. So what's happening in discrete random variable? It will take either finite, limited number of values or unlimited, countably infinite number of values. In infinite number of values, there are two categories. In infinite number of values, we are having two possibilities. Uncountably infinite or countably infinite. If it is countably infinite, that is called as a discrete random variable. And next definition comes for continuous random variable, that will be uncountably. Just to see here, a random variable is called continuous if it assumes uncountably infinite number of values. Now probability function, there will be a probability function for every random variable. So if the probability function is discussed for a discrete random variable, then that is called as probability mass function. If probability function is taken for continuous random variable, it is called probability
Mass function.
no, continuous. Then it will be
Density
called
function.
density function. Now you see that next variable, next definition. Now this is very important concept now. That is, the expectation, full name is mathematical expectation. This mathematical expectation, or in short expectation, it is also called very simple names, that is mean or average of x, denoted by E of x. Expectation E, expectation of x. How it is defined? Because it is random variable, it may be continuous, it may be discrete. So there are two definitions now. I mean two possibilities. So simple, keep in mind. If x is discrete random variable, just x values you multiply with the probability values and take the summation. Be careful, this is sigma and this is E. Don't be confused and don't write here E in E of pi xi, or don't write sigma x. Be careful about it. So here probability value is multiplied and summation is taken for discrete. Here probability value is multiplied and integration is done. This f of xi is nothing but value of the probability for a continuous random variable. Xi is xi here. Here pi is multiplied, here f of xi is multiplied, where f of xi is probability function. Probability function, that will give you the probability value. That probability value you are multiplying with xi and doing integration. Simple. For discrete, sigma will come. For that continuous, integration from minus infinity to plus infinity. But in practical cases, even though it is allowed from minus infinity to plus infinity, it will exist between A and B. A and B. So you have to do the integration from A to B. Okay. Listen here. This is very useful formula. Expectation of x square means what? You have to use x square. P into x square. That square is not for P, it's only for x. So if x square is written here, expectation of x square, then x square will come here and pi will come. Okay? And same x square. But if it is x cube will come. Means what? Whatever function comes here, that same function you have to use it here. That g of xi into pi. Here it is g of xi into f of xi. Instead of just xi, you are having g of xi. I hope you understood this.
Yes, sir.
And one more important formula is variance of x, that is expectation of x square minus expectation of x whole square. So if you calculate e of x and e of x square, variance is done. And they will be asking calculate the mean and variance. For mean you have to calculate e of x. For variance you have to calculate e of x and then use this formula. Next. A random variable x has following probability distribution. Find k, mean and variance. Now x equal to x, p of x equal to x. Means this is xi, this is pi. Adding all the probabilities, what you will get? 1. So you are adding, we know that sigma pi is equal to 1. So adding only
sigma
probabilities, you will have that k here. So finally k comes from this one, that you know, okay. K equal to 0.2. So mean of x is how much now? Expectation of x. That is nothing but sigma
pi
xi. Probability you are multiplying with xi. Probability is k multiplied with 4. I hope you understood what is sigma pi xi. You are just multiplying that first number with the probability, second number with the probability, adding all that products, you will be getting expectation of x. How much it is? 7.1. By taking k value we came to know it is 0.2. Now what is expectation of x square? That is x square into pi. So x square is 2 square. Probability is as it is, you are not multiplying, you are not taking the power for this. So x is 2 square into 0.1, similarly so on. Finally you will be getting 56.9. So that is expectation of x square. Variance of x equal to
expectation of
x square minus expectation of x whole square. 56.9, we got to mean as 7.1. So on simplification it is 6.49. A continuous random variable, keep in mind, for discrete random variable, finite number of values will be there, or infinitely many values but countable. So you can have a table, but uncountable infinite number of values for continuous. So you cannot have a table. At that time there will be a function. So that function f of x, I was saying xi into f of xi, that is this f of x. Okay. So it is kx between 0 and 2. Between 2 and 4, it is 2k. Between 4 and 6, it is this one. So it is working from 0. It is defined from 0 up to 6. After 6, it will be 0. Before 0, it will be 0. So it is defined only between 0 and 6. Find k and mean of x. We know that the integral, instead of sigma pi is written with f of x.
Yes, sir.
Integral will come instead of sigma, that is equal to 1. So we have to integrate that function from 0 to 6 because it is existing only between 0 and 6. So we have this one. Now that 0 to 6, there are 3 different behaviors. So 0 to 2 it is different, 2 to 4 it is different. So this integral is broken into 3 parts because 3 different behaviors are there. Now I am substituting the behaviors. In between 0 to 2, function f of x is kx. Similarly it is 2k, similarly that one third. Okay? Now k comes out constant, integral of x is x square by 2, okay, plus this 2k outside, integral of dx, okay, integral 1 dx actually it is, this is nothing but x, lower limit, upper limit. And here 6 minus k is out, integral of x is x square by 2, that is equal to 1. So if you simplify this, you are getting k is equal to
59
by 4. Define the following, that is binomial distribution and Poisson distribution. Means you have to write the definitions just. So a random variable is x is said to be satisfying
Binomial
or is
distribution.
said to satisfy binomial distribution if its probability function. Just now you noted f of x is some bracket value, three different behaviors are there. Similarly, what is the probability function for this binomial distribution? That is nothing but this one. It is which case actually? It is the case with discrete. Not that three brackets. Okay. That we are written for continuous. Simply speaking, there is some probability function for this distribution. So that variable is said to satisfy binomial distribution if the probability function is in this way. Probability of x equal to r is NCR p power r q to the power of
n minus
n minus r. R takes the values 0, 1, 2, 3, so on up to n, because NCN is the last one.
Yes.
Okay. Memorize that one, very important. P of x equal to r is NCR p power r q power
n
minus r. A random variable x is said to satisfy Poisson distribution if its probability function is given by p of x equal to k. E to the power of minus lambda, that lambda is mean actually, that lambda will come here, power will be this k, and that k factorial will come. That's the definition, remember. What is p of x equal to k for Poisson?
e to the power of minus
E to the power of minus lambda into lambda power k by
K factorial.
k factorial. Now, a die is tossed how many times?
9 times.
9
Nine
times.
times.
What is the probability of getting
2 or 4.
2 or 4?
At least
At least
Seven
7 times. How is the problem? First you analyze the problem. If you conduct this experiment, means you are taking a die and tossing it. What are the possibilities? 6 possibilities. Out of that 6 possibilities,
They need to
getting 2 is success,
Yes, sir.
getting 4 is success, getting other numbers is failure. If it has only 2 categories, one is success, one is failure, then we will use binomial distribution, keep in mind. So when you conduct an experiment, you should be able to decide outcomes into only 2 categories, success and
Failure.
some outcomes come under success, some outcomes come under
Failure.
failure. What is the probability of success? We will call P. What is the probability of failure? We will call Q. P plus Q will be equal to 1. So either success or
Failure.
failure. If you add it, finally 0, that one will come 1. So is this point clear? Now you are tossing a die. How many times?
9
Nine
times.
times.
9 times.
9 times. Suppose first time 2 has come and 4 has come. Means 2 has come or
4
4 has come. Is it success?
Yes, sir.
Do we need that in our counting?
Yes, sir.
Yes. Suppose that neither 2 has come nor 4 has come. Means it is failure. That is not counted in our case. So, if you conduct it 9 times and 2 and 4 has not come, all the 9 times, means how many successes we got?
Zero.
Zero. What are the values now? That random variable will take either 0, no success,
Yes, sir.
or 1 success, or 2 success. Suppose every time you are tossing, every time you are getting 2 or 4, 2 or 4, 2, 2, 2, 4, 4, 4, like that. Means all are success. So how many maximum successes?
9.
9 successes. But what is asked here? At least
Seven.
7 times. What is the probability? Then, so simple, what we are going to do here is n is equal to 9.
Yes, sir.
Yes, sir.
N is equal to 9. 9 times it is tossed. What is the probability of getting success? 2 or 4. So 2 chances out of 6 chances. That will become
1 by 3.
1 by 3. We know P plus Q is 1. So Q is equal to 1 minus P, that is 1 minus 1 by 3, that is equal to 2 by 3. We are ready with that. Now, what will be the formula?
NCR.
NCR, P power R, Q power
N
N
N
minus
minus R. For R successes. That is for
7.
R successes, right? Now, probability of getting 2 or 4 at least
7
times. Means either 7 times or 8 times or 9 times. Whenever R is there, that plus will come, keep in mind. Okay? So what is the probability of getting 7 successes? Here I have written the general formula. What is that? I have given this all as first equation. We have to add up all the 3 things, but all of them are calculated as per binomial probabilities. So P of x equal to R is 9 CR, because NCR, that is n value 9.
Yes, sir.
Totally we are having 9
Nine.
tosses. So success may be 7 times, maybe 8 times, maybe 9 times, that all we need to calculate. So For R will come here, R will come here, n minus R. So by substituting R as 7, 8, 9, we'll get like this. For 7 times how much it is? 9C7.
9C7. 1 by 3 power 7.
This is P power R. This R will come here,
Yes,
and n minus R means 9 minus 7. That 9 minus 7 is 2.
2.
But instead of that, you can simply say this 7 will come here, and the balance power is 2 to make it equal to this 9.
9.
So 9C3, 9C8, 8 here, balance is 1 power that has come. 9C9, 9, so this is not getting used, 0 power. I hope you got it. If you add up all these things, then you will be getting 9 probability of x greater than or equal to 7. Understood the points?
Yes,
So
sir.
this list of 30 questions, if you really practice, then there are high chances, 99% chance that you will get problems of this model and you will be able to do it. Remaining problems we see in the next class, okay? Next. Thank you.